Hello everyone, thank you for joining us today. Today we have a session about adding real-time web functionalities to your applications. My name is Hassan Mohsini, I'm the program manager for Microsoft Reactor in Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry-leading ideas and technology from Microsoft partners and the open source community. It's also home to the Microsoft for Startups program, with a diverse mix of hands-on workshops, expert panels, and community events. There is something for everyone. Check out our calendar of events on meetup.com and join our coming sessions. Our speaker today is Rami Sarieddine. Rami is a senior cloud solution architect at Microsoft with 14 years of experience across industries and wealth of domain expertise on developing and deploying cloud native solutions. Rami has been mentoring startups in the UAE for the past 6 years, and he is also a published author with 2 titles on web development technologies. During the session, you can keep the Q&A tab open and send us questions. I will be also sharing some links and resources to things that you can continue the journey with, and you can send us questions as well during the session, and we will have stops to answer these questions. And with all that, I would like to hand over the mic to Rami to start the session. Off to you, Rami.
Some time to unmute. Thank you, Hussam, for the introduction, and hello everyone. Thanks for taking the time to join. Hope that this session will be beneficial and you'll be able to walk out with some new learnings and some technical acumen, and hopefully you'll be having some technical knowledge that you can apply to the scenarios and use cases that might be relevant in your startups and in your solutions. Let me take over, Hussam, if you don't mind, and forgive me if I'm not always facing the camera. I'm on 2 screens. So there's a screen where I'm presenting, and there's the screen where I have the live. And if I may, I will share my presentation for today.
It's all good.
Perfect. Well, thank you. And we are good to go. So our session today is on developing real-time functionalities or features to your web applications. To your web and mobile applications, basically, these are the 2 main buckets, if you want, of clients that use real-time features, although you can also apply it to desktop solutions or just interfacing of messages. Now, to get started, I want to quickly touch base on some of the real-time scenarios that you will find, and now it's more important than ever that we have this collaboration in place, because everyone's working digitally, at least in one form or the other. We have this new challenging situation where we need to collaborate and we need to do things in real time. And you have software that does this, you have software that has these features, but when it comes to you building your own solution, your own software, your own services, and incorporating these features or functionalities, that's where this comes in handy, and that's where this is beneficial. Now, as you can see here, these are just a highlight of some of the real-time scenarios that you can use, but as you can see, they're everywhere, right? You're co-authoring. You have real-time location-based tracking. You can think of IoT solutions, shipments, and what have you, and distributed systems around the globe. And also another feature of real-time scenario is in-app notification. Very relevant these days when you want to push notifications in real time related to so many things, from healthcare to financial scenarios in banking, in stocks, and also maybe things related to field line, first line or field workers, where they need to be notified and take action on the spot. So this is what in-app notification is all about. It makes sense that this is not passive, this is something active. And another solution area is live dashboard. Also, live dashboard is very important when you need to keep track of things and make sure that all of this is real time. For example, I'll take healthcare, for example. If you have a dashboard for ER patients, this is very critical that this live dashboard includes all the important information and it's in real time, because you're checking the patient coming from one from one section to the other. And if we go to typical scenarios under each, as you can see, for example, here in banking, market live data, trading, very essential. You need to, especially if it comes to stocks and trading, that's a second by second scenario. Education, as you can see these days, between collaboration, interactions, live video broadcast. Of course, government now, very prominent scenario with voting and polling. Also messaging, that's given, you have it everywhere, messengers, live chats, collaboration. Gaming, that's another scenario where you have gaming and group gaming and online gaming. E-commerce, where you're contacting support, chatbots, very important. You're talking to a chatbot, you need something instantaneous with feedback. And as we move forward, if you can see, for example, targeting of advertising, push ads, connected devices, smart home, smart city. I recently bought this vacuum cleaner that I can use with my app. It's amazing, and I'm pretty sure it uses these real-time scenarios, because I can send it back to its charging dock. I can have it clean some spots while I'm outside of the home. So remote control, status, location tracking is very important. So that's in terms of market segments. As also, if you move to real-time messaging scenarios, as you can see here in real-time chats, you have one-to-one scenario, one-to-many, many-to-many, of course, and via a server. You can think here of group chat, in-game chats, chatbots, and messengers. While real-time data update and broadcast can be at the producer-to-consumer level, producer-to-consumer or consumers, and this is one-to-many. Dashboards, of course, one-to-many, scoreboards, real-time data on charts, on maps, satellites, pricing updates, and what have you. In terms of events, if anyone has an event, of course, you would need to update on the status of events with indicators, event triggers, devices. This can go into under event-driven type of scenarios where you can use serverless computing with it and integrate real-time features, because not necessarily every event-driven scenario is a real-time. So here you're augmenting or you're complementing the solution with a real-time feature. Of course, high-frequency real-time streaming, as you can mention here, voice over IP streaming, real-time gaming. Now, typical client types for these, as I mentioned earlier, the two main buckets of clients are web solutions and mobile browsers, also desktop applications, mobile apps, and server processes. IoT devices is very important also scenario, as you can see now in all of this modern devices that you get home, like the robots, the home security cams, and all of those, you know, now with smart home, things like Nest and what have you, we can control. So these are IoT devices where you basically have a medium of real-time integration, be it unidirectional or bidirectional, in a sense that you're just receiving, or in a sense that you're actually sending back some actions to the device. So with that in mind, as you can see, plenty of scenarios, a lot of things come together in terms of use cases. Some things intersect and overlap. But if we want to shift gears and talk about the technology that allows you to do so, now, of course, you have plenty of solutions out there between technology platforms, development platforms, cloud technologies, and SDKs and what have you that allows you to do so. But I will be walking you through some of the services that you can use on Azure to achieve this in a fairly quick manner. So back to the point on technology and how can we solve this and how can I solve that with technology. So that's where I can introduce SignalR and welcoming SignalR service to the stage. It's not a new technology, albeit the service itself in terms of a managed service is fairly new, but in terms of technology, it has been there for some time, and I will be walking you through some of that history. So if I want to start, I'll start with SignalR itself. Before I talk about SignalR service, I can talk about SignalR itself. So SignalR is an open source library. You can use it to add real-time web functionality to your apps. It supports bidirectional server-client communication, which is very important in real-time applications. It allows you to send messages to a specific or a group of clients. That's typical to anyways type of pub sub scenarios where you're publishing or broadcasting. It uses WebSockets, so server sent events and long polling transport support. And also SignalR can replace user polling and Ajax long polling commits. So that's for some of you who've been using it. Back in the days, you've had similar scenarios, and you can achieve it with user polling and Ajax long polling or commits. And if you want to basically picture this in a very simplified manner, previously when you wanted to get to such scenarios, you would be pinging the server, right? This is called polling. You're pinging the server all the time and getting information. Did this update? If there's a refresh, keep refreshing, keep refreshing. So that's how you can do it if you want to strip it down and do it just manually. Also, SignalR enables connection management, group connections, and it has authorization APIs, which is very important when you want to achieve that extra level of authentication, authorization, and security and roles. And it allows you to scale because it has a backplane with Redis and SQL Server, or you can use Azure Service Bus also. And with SignalR, of course, now complemented. We're talking about ASP.NET Core also, so that builds on top of the original ASP.NET SignalR. You can transition from non-core ASP.NET back in the days from to the new ASP.NET core SignalR. Now, SignalR, basically, as you can see here in this illustration, you have a client here, you have the SignalR hub, and then you're sending out messages to the hub, and then the hub is broadcasting this back to the clients. So you have the server, you have the hub in between, and it's basically polling messages, pushing it, and enabling this real-time experience. But the SignalR hub is the component that simplifies all of that process. And if I want to just, as I mentioned earlier, it's not new, so there's some history to it. And if I want to walk you through the journey of SignalR, it started back in 2012 with ASP.NET 4.5. And back then, the intent was to add real-time web functionality to your ASP.NET application. And basically, back to the slide. As you can see here, you have a server application, .NET, and then you have a client application, basically your HTML and JavaScript being serviced to the user. And the idea was that you invoke the server with a client method, and then you have a connection. That's what the SignalR hub does. It opens that connection between the server and the client, and you are able to establish this between the hub proxy and the hub server, and exposing this through your client-side code. It included persistent connections and hubs, and it was implemented based on WebSockets, server-sent events, and of course long polling. Now, fast forward, we have a managed service. We can still implement it the old way. You can use self-hosted SignalR, so you can take a SignalR hub, host it on your web app, and implement this. And you can also use a SignalR managed service. As you can see here, SignalR will scale independently, and some of the features that you can benefit from here is the fully managed service. It will allow you to have capacity provisioning, scaling, or connection management done independently. So you don't have to worry about capacity provisioning, as I mentioned, scaling or managing the connections, because that is covered in the managed service. And it's good because it allows you to have that isolation, or if you want that dependency being taken care of. And you know that, for example, here in the self-hosted, if the server that's hosting your SignalR hub fails, well, everything else fails. While here the SignalR service is scaling and being run independently, so it can give you that scenario where you have more of a modular approach, that they don't fail together. Maybe you can write something in the code that allows you to have a workaround, what have you, but at least here they don't fail together and they scale independently. Now, as a native ASP.NET Core SignalR, here you will have the support, so nothing changed. But in it's an addition. You will have new possibilities because you can integrate that as a service directly to other services in Azure, and it's now going global into a lot of regions. So the availability is there now. Going back to SignalR itself, I just wanted to land home some final ideas. So if I want to simplify this, maybe in a tweet, SignalR service as a managed service basically allows you to simplify the addition of real-time web functionality to your application over HTTP. Now, this real-time functionality, as I mentioned earlier, and I can iterate here again just to land it home in terms of an idea, it allows the service to push content updates to the connected clients. You have content updates coming from the server, you have few connected clients, it pushes these over, and you can think of scenarios like single web page, a mobile application. And as a result, the clients are always updated without the need to poll the service. Poll the server. So that's the whole idea. If you want to, because as I told you, you can do this, and it was done previously, where you would be polling the server and you would be submitting new HTTP requests for updates. But that is an overhead, and if you're familiar with the intricacies of HTTP requests, there's a lot of overhead, and that can slow down your application, and it will, as I told you, not be the most efficient manner, although it can be done. So what the SignalR service will do is basically give you as a feature, as an outcome of all of this, your clients are being updated with new content from the server that's being pushed without having the need to poll the server all the time. Now, we mentioned earlier the scenarios that apply in terms of business scenarios or use cases, but also take all of that aside. You can also simplify it to to easy terms, any scenario where you would require pushing data from a server to a client in real time, basically can use Azure SignalR server, SignalR service. So traditional real-time features that often require polling from server can also use that service. And as you've seen in the first slide, you can use it across a variety of industries. And you know, not gonna iterate. We talk about the categories between real-time location mapping and collaborative apps and what have you. But maybe I mentioned one very unique use case now, automation, and you can now see the prominence of automation coming across the board. So automation can be a very good candidate where you can have real-time trigger from upstream events. And to also address the point that I raised, that you can do this in a different way, and you might ask, okay, so why SignalR service? What are the benefits? If you want, there are a set of features I will talk about in the next slide. But if I want to address this very simple question, what are the benefits of using SignalR service in this case? Well, first, it's a standard based, right? So it provides an abstraction over a number of techniques that you can use to achieve this and to build real-time web applications. Now, WebSocket is the optimal transport mechanism here, but there are other techniques. You have server-sent events, SSE. You have also long polling that were used when other options were not available. At SignalR, basically automatically, and that's the beauty of it, it automatically detects and initializes the appropriate transport based on the features supported on the server and on the client. So standard based, and of course that automation layer of the transport mode. Also, for people who use .NET Core, it has native .NET Core support. And it has a broad client support. So when you use technology like this, you always think of, okay, I have clients that can vary in terms of technologies, and you want something that can address this. So SignalR really delivers on this ask. It works with a broad range of clients, so web, mobile browsers, desktop apps, mobile apps, server processes, so something that doesn't even have a client interface, IoT devices, game consoles. And in addition, the SignalR service offers you the SDKs in different languages. That's very important. Not everyone will be using .NET or .NET Core, or you can have it, of course, if you're familiar with it, with C# SDKs. But also SignalR will provide you JavaScript client SDKs to enable web clients and many other JavaScript frameworks to integrate. The Java client SDK also is supported for Java applications, so that's including Android native apps, and of course REST APIs are supported, and you can use REST API. Now, in the case of integration with other services, if you are using serverless technology or functionality on Azure, like functions or event grid, you can also integrate with Azure SignalR service. Another feature. Let me maybe move the slide so you are able to see. So some of the things I already spoke about, I will continue to cover the rest. So you have the scale. So it can handle large-scale client connections, and that's very important in solutions where you need that. You have applications that connect to millions of client connections, and you have solutions that require really large-scale real-time applications. You're talking here like trading, like games, and what have you. So imagine all that load, and you need you need to have multiple instances, and that's where the SignalR, as you've seen in the previous page on the slide, where we talked about the managed SignalR service, that the service itself now can scale independently, right? So it allows multiple instances to work together, so you can scale to millions of client connections. And given that you have multiple global regions, you can also support sharding, you can have support for high availability scenarios, and of course disaster recovery purposes, now very prominent these days, given the you know, the high dependency on having these be uptime most of the time. Now, last feature, also very important, is the if you want to use the, so the features previously mentioned basically apply in scenarios where you don't need to use the managed service, except maybe for the last one where I mentioned large scale connections. It's easier to have it with SignalR service, but this feature that I will address now is basically catering to the SignalR service itself as a managed service. So very easily removing the burden to self-host a SignalR, because if you compare it to the self-hosted scenario, switching to the SignalR service will remove the need that you manage the backplanes that will handle the scales and the client connections, because that will be in with the web app. The fully managed service will simplify it, and it will also simplify the way the web applications handle it, and of course saves you on the hosting cost. And given that it has global reach, of course that will automatically address the scalability piece, the SLA that comes with it, and the compliance and the security that you can apply to it. That's very, if you want, high touch list of the features. Just trying to skim through here things that I might have missed. On the DevOps, of course, the tooling is there. You can connect it to your DevOps processes or DevOps platform that you are using now. As I mentioned earlier, in terms of platform compatibility, it has rich X platform between SDKs and libraries. And if you're on Azure, you have the management via the Azure portal. We can go to the Azure portal and create it and manage it. And of course, it connects to the monitoring dashboards that we have with log access. So great support for the DevOps piece. And in terms of performance and scaling, performance and scaling, you have the Redis-based backplane scaling that allows you to achieve that high level of performance and scaling. And of course, you have a load balancer layer 7 because it sits at that level. And a very good SLA, you're talking 99.9% uptime on the managed service, and the latency here, optimal latency on server side with 99% of the messages transmitted less than 1 second, which is a very good number. And we mentioned the integration with the authorization layers, so that allows you again to address the authentication, the security, the access control, and what have you along these lines on the service itself. Moving forward, a question can be asked: who may use it? Well, it's very easy to conclude from what we talked about earlier. Any use case where you would need to add real-time features to an existing web app or a new web app, outsource SignalR backend. So you have SignalR backend, as I mentioned, you can have it manual. If you want to outsource that, you can use the SignalR service, or if you're building a new real-time web app altogether. Unique benefits from an ASP.NET Core perspective, if you've been using it with .NET, it has improved performance, of course, stability, now cross-platform, and of course native dev and tooling support in that front. Now, from an Azure infrastructure perspective, because eventually it's hosted on Azure and offered through Azure data centers. You have global reach, you have the SLA, you have the scalability, you have the security and compliance that comes along with it. You have monitoring that you can easily plug into it. And of course, other services that you can also easily integrate with, between storage, between app service. So let's say you have a scenario where you need to, the client needs to get something from the storage. It's easy. You don't need to write a lot of code. That service can integrate with the storage blob on Azure and get the information that you would need from the blob. If you have an analytics MBI engine, which is great for dashboards and live dashboards, you can connect to that BI service and the analytics service and be able to seamlessly integrate those into your solution. Of course, IoT scenarios and AI if you're using AI cognitive services. So it comes with a lot of benefits, needless to say. Now, given that we know what it does, why would we need it, and what are the benefits, we move to the how. So how can we use it? It's easy. On Azure, you can just go to the Azure portal, and maybe when we're done, if we have time, I'll show you. Go to the Azure portal, you look for SignalR service, you create it. It's a standard Azure service experience that you would expect from any similar services. It has ARM template and CLI support, which is great if you want to automate this from a DevOps perspective. If you've been using ARM templates or CLI to create your resources on Azure, there's no change there. You can still do so with the Azure service. And as you can see, let me highlight here. Maybe the highlight, the pen. So as you can see here, when you create that service, you have automation options here. That piece will show you things related to the ARM template and what have you, and we'll look at these later when we go to the portal. Also, you can program with these very easily. Once you create that service, so here the service is created, you can look for the keys. You can get the connection string, as you can see from here, and you can use the access keys to authenticate your SignalR clients when you make requests to this Azure SignalR services. Okay, maybe for demos, POCs, you might not need to, but eventually in a production scenario, of course, you would need to secure that with a proper authentication layer. So you can store your access keys securely here on Azure. And if you want, you can use Azure Key Vault, and that's additional, of course, feature when it comes to keys, and you don't need to share them. And in this case, you can just integrate seamlessly. So as you can see, if you want to program with it, very simply, step number 1, copy paste your connection string. Then you go to your application. Step number 2, you configure the SignalR SDKs based on what you have. And then you start coding with the SignalR APIs. Once you establish that connection with the hub, and when you're done, you can just build and deploy to Azure, and that's it. So 4 main steps. Of course, underneath there's a world of things that you can do, but as you can see, at least the first 2 things are very easy. Get a connection string, configure the SDK, and then start coding, and that's it. You have this up and running on Azure. On this slide, you can see a very simple reference to the SDKs. If you're using .NET, as you can see here, you can go to the service SDK, you have a package reference, you include it, and that's it. You're good to go. And if you're using client SDK, .NET and GS in this case, you link it to the Signal service documentation. And now you, of course, you have the Java client, as I mentioned, and there are more to support different platforms that is coming soon. But with what you have now, it covers a broad range of platforms, as I mentioned earlier. When it comes to developing, as I mentioned, you have the 4 steps that we talked about earlier. So you get that connection string and you go to your application. And once you reference the SDK, it's very simple. Now you have that service. This is a snippet from a C# file, the startup.cs file in a .NET Core application. As you can see here, when you're configuring the services in this public method, they're adding a SignalR service, and it's being initiated here. And then once, so that's configured, and then on the app itself, so here at the service level and here at the app level, as you can see, the app is using the SignalR, the Azure SignalR, and then it's adding the routes to the map hub itself, and then it's linking to a chat page where it has that extra code for the chat application. We can see that maybe once we're done on a sample file. In terms of .NET support, as I mentioned, the SignalR service is based on ASP.NET Core and its APIs. So if you have an ASP.NET, if you have a web application on ASP.NET, easy with ASP.NET SignalR SDK. And if you have an ASP.NET web application, on ASP.NET Core, you can use the ASP.NET Core SignalR SDK. As you can see here, it just requires an updated SDK, and you're good to go. Once that added, it just uses the Azure SignalR service on ASP.NET Core SignalR. Now, if you want to just dissect the way the connections and the message sequence happens, as you can see here, a generic connection and message flow between the client, the web server, and the SignalR service. So you have the SignalR client, that's the SignalR service on Azure. This is your web server, the hub, and that's your client. So you establish a connection, and then you get a response back. Then you open that WebSocket connection, sending to the service, and then the service sending back the result. Now you establish that connection good, and then afterwards you start making those calls, and here send, basically you're from the client to the service. You have a call, and then the SignalR service, of course, abstracting that communication with the hub. It will get the content updates, send it back to the service, and then, of course, the client here is just interfacing. So the client is just interfacing with the SignalR service, and of course, abstracting this layer here in the middle where the hub is communicating with the SignalR, and it's sending back the results in real time. And we can maybe look at a simple scenario there. Before I go to thank you, of course, because that's we're not done. Let me stop sharing, and in a second, I want to share my browser. And I hope you can see my my browser. Let me go back to the chat, see if there's anything in the Q&A. And I can get a sip of my tea.
Yeah, your screen is live, and we got some questions on the published side as well. So whenever you can, yeah.
Okay, so I'm thinking, Hussam, I can take a pause here and address the Q&A and then move forward, or should we leave the Q&A?
There are a few questions that are related to parts that you already covered. So you might be able to address the questions now or later. It's fine.
Okay. Look, so some of the things I can address now. So a very important question: self-hosted versus managed SignalR Azure. So what are the differences? Look, I'll be very transparent. I have these here on the public facing documentation. So whatever I'm presenting is a publicly faced documentation and fairly recently updated. So the differences, basically you have between the two. This article will detail the features that have been removed or changed. Now, feature differences. You have, for example, automatic reconnects. In ASP SignalR in ASP.NET, the SignalR by default will attempt to reconnect to the server if the connection is dropped. In this core, in ASP.NET Core, the automatic reconnects are opt-in. Okay, so that's very important because sometimes you might forget to opt in, right? So automatic reconnects are opt-in with both the .NET client and the JavaScript client in both clients. As you can see here, when you're establishing the connection, so Hub Connection Builder, automatic reconnect. So you add this, so you're opting into it. Another key difference is the protocol support. Well, of course, you might not need to worry about it, but worth mentioning. So the .NET Core SignalR supports JSON as well as a new binary protocol based on message pack. The .NET previously did not support that. So also with the new with the .NET Core, you can use you can create custom protocols, which was not the case. Another key feature at the transport level, forever frame transport is not supported in the core SignalR, although I don't think that will matter if you're building now a new application altogether. It wouldn't really matter unless you have a migration scenario, but you can just maybe try to do it from the scratch with the new one. There are some differences on the server, as you can see here. The core SignalR server-side libraries are now included in the .NET Core.app, which is used in the .NET Core web application template. The SignalR, the .NET Core SignalR is an ASP.NET Core middleware. And now you can configure it by calling the add SignalR in the startup.configure services. As you can see here, that was the snippet from it. Now you can see to expand, now they're configuring the routing. So you map routes to hubs inside the use endpoints, which is again in the startup.configure method. Differences on the server too, we're talking about sticky sessions here. You have the scale out model for the ASP.NET, which allows clients to reconnect and send messages to any server in the farm. In the .NET Core, the client must interact with the same server for the duration of the connection. So that's a stark difference, right? In the .NET, you had you can connect to any server in the farm, but the .NET Core should explicitly be interacting with the same server for the duration of the connection, unless you drop the connection and connect again. For scale out using Redis, that means the sticky sessions are required to achieve this. Now, of course, when it comes to scale out, there is a certain mechanism for scaling out with SignalR service. So that's why sticky sessions aren't required, because the service itself handles the connections to the client. That's the difference between the self-host. What else? Also on the server, single hub per connection. The .NET had a connection model with that, but now with the new .NET Core, the connection model itself has been simplified. So now the connections are made directly to a single hub rather than a single connection being shared to being used, to share across to access to multiple hubs. The .NET Core supports streaming data from the hub to the client. Also differences on the client here, you have dependency injection. The .NET Core has dependency injection built into it. What else? Hub pipeline. The core does not support it. Now, differences on the client. TypeScript. So anyone, if you're using TypeScript, so the SignalR client is written in TypeScript. You can write JavaScript or TypeScript when using the JavaScript client. The JavaScript client is hosted at npm, while the .NET versions, if you recall, if you're using it, it was obtained through the .NET, the NuGet package manager in Visual Studio. While here it's just an npm, you can install it. It's very easy. So you can see npm init, and then you npm install Microsoft SignalR. What else? jQuery. If you also recall, if you've been using the dependency on jQuery has been removed, but you can still also use jQuery, but it's not a dependency anymore. .NET, Internet Explorer, very important for some applications, especially internal applications that rely on it. The ASP.NET Core supports Internet Explorer 11 or later, whereas the SignalR itself supported IE 8 or later. That is a key factor if you have internal applications. Granted, but if you're having consumer-facing applications, well, of course, most of the people will be using new browsers, so that's not an issue. But sometimes you see in enterprise or some internal systems where you have dependency on a browser version, of course, this can be showstopper, but you can always check the supported platform page that lists the browser support. I'll stop here, but look, it's very easy. You can just go to the SignalR documentation and you can read the differences. I just wanted to skim through some of them, the main ones, and then you can see the rest. Let me go back to the chat. Will we be? So that was Hussam. No need to answer Hussam. Which is preferable for push notifications? Notification hubs or SignalR? Well, I can show you here. This is a cross-platform chat. That's an architecture high level. You have SignalR service, and then you have a client and an app service. As you can see, the app service will connect to the SignalR service, and then, of course, connection with the key. You can have an authentication layer, and the app service will communicate to the client. And if you want to see the data flow here, the web chat app, which sits here, connects to the SignalR service and receives the token for authentication. The user will log into the app with multi-factor authentication if needed. That's very important because you can enable it. And if passed, so once authenticated, the SignalR endpoint will, and the bearer token returned, the user will be logged in, of course. Then the user will connect to the SignalR service with endpoint and token. Once you have the endpoint and token, that's it. You establish that cross-platform chat, and you are able to initiate that and start it. Sharing location, another reference architecture here, scenario, but we're looking at the scenarios from a technical perspective. So basically here, as you can see, you have a service bus queue. You basically, also the potential use cases, you have real-time location. You're sharing the real-time location with client devices, and you want to push notifications to the users by updating the timelines and creating chat rooms. So let's say a delivery person. Okay, our delivery person here, he has a phone that is running. So that's the client, and he has the mobile app running on it. The device itself is sharing the GPS all the time, and there's the service bus queue in between receiving that. So the service bus queue could have been here maybe an event hub. So that's why the components can differ, and as long as they're fulfilling the functionality. So you're collecting data, and you're using a trigger with Azure function. So the Azure function will always look at the queue. The queue is the trigger. If there's a trigger, okay, what do we do, Mr. Function? You just initiate a SignalR call. The SignalR, which is also here, so serverless to serverless, it's sending the GPS to the mobile app, and then the mobile app is being updated if you want to do here any sort of processing and what have you. So this one shares the GPS information, and this here sends it to another application that is with someone else. Maybe this mobile app is with the user, right? I ordered and I want to see if Zomato, what have you. So that's how you do live tracking, maybe with Zomato. But of course, they might have been using a similar architecture or something more complex or more simple. But this is a very rundown version of it. As you can see here, if we want to double click on the components, as I mentioned, service bus is a cloud messaging service. So it just sits between the application and the service. Even in this case, when offline, that's the importance of the service bus queue here. The SignalR makes it really easy to just add this real-time communication to your web application or mobile application. The Azure Functions, which sits between the queue and the serverless, and the SignalR service, is an event-driven platform that basically adds orchestration, addresses orchestration scenarios, or you can just add here in the function some sort of code that does extra processing, right? So that's one scenario. Instant broadcasting, another feature here, another use case, simplifying one-to-many real-time communication and updates using serverless code. So you have SignalR, and then you have the client, that's the web app. You have functions here in between. You have the SignalR service. And the storage blob picking up some things to broadcast maybe. So that's a media scenario, as you can see. Now, if we want to look at the data flow, first, you have the client pulling web app content from blob storage, okay? And then the web app service here, number 2, receives a SignalR token and an endpoint to establish a connection. Then the user will connect to the web app. This is number 3 here in the, let me draw, no, I can't draw here. So number 3, so here, that authentication layer, so having user connecting to the web app, and then the connection will trigger between the app and the database, maybe via functions or something, and then the functions that are sitting here can push data to SignalR service, and then the SignalR service in return pushes data to the client. So that's the journey from the client to the client, where you're broadcasting easily the content back to the client. That's also one form or the other. Now, someone asked a very important question: which is preferable for push notifications? Notification Hub includes extra features that are catered for push notifications. Okay, so you can use SignalR and Notification Hubs to implement maybe a real-time scenario, but Notification Hub includes with it the commonalities of mobile push notifications, between having the same template pushing to Android and Apple, the connection strings to those services and what have you. So the Notification Hub is a full-fledged service that is catering for mobile notifications, because it has to connect to the APNS server or to other, I think, forgot the name of the server that sits on the Android front, and have this all abstracted for you. And if you recall, also you have templates that differ between clients, which is the device, an Android tablet, an Apple, or a web application. So Notification Hub simplifies all of this. So that's why I think it's a critical component to use when you have a mobile notification scenario. How easy is it to integrate with SignalR with Azure Functions? It's very easy. Maybe we can go to the Azure portal and since we have some time, let me check. Yeah, we have 2 minutes. Actually, I wanted to show you also some code. I don't know if you can see. I don't think you can see my screen. I'll share the Visual Studio screen. So I have a very simple scenario, which is a chat application, which I got this actually from the GitHub repo, and it shows you a very simple scenario where an application is connecting to a SignalR hub, and the startup page basically includes a configuration layer where you just open a configuration to use the web API, and then you call the map Azure SignalR method. And basically, you configure the authentication layer with the application itself, and the code is very straightforward. You connect, and then you broadcast messages, and you receive messages, you send them to a group and what have you. It's a very simple application, and you can check the code on, let me go back here, on SignalR samples. You can go to github.com/asp.net/Azure SignalR, or just on a GitHub page, just look for SignalR samples. You will be able to find them. And it's great because you can easily fork the code or just clone it to your local dev tool and start using it. You have a chat room example. You can also build one from scratch. Let me see, this one will show you. You can go to the Azure portal, go to web, SignalR service, you create one, and then you just mention the resource name, the subscription that you have. You fill in the information, the pricing tier in terms of scaling and connections. You have here 1K connections, up to 75 million messages, and it has SSL and an SLA. So these are the pricing tiers. It gets deployed, and once it gets deployed, it's easy. As I mentioned, you go to the keys page, you get the connection strings, and this is the connection string that your application can use to connect to the service. And you just go to the code that you have here. You have a simple chat room .NET core application. You can see that in the startup page, you simply call the add Azure SignalR, or after the add SignalR, and pass in the connection string. Services, add SignalR, add Azure SignalR. You pass the connection string to make the application connect. And then once you establish the connection, and you of course reference the SDK before using the APIs, and that references the project file, and then you're good to go. You have a connection, and now you can start talking to it. And basically, you open the web page locally in your IIS Express, what have you, browse to the local host, and you can see the application running as usual, and it's connecting to the SignalR service on Azure. That's as simple as building a web application that is connecting to it. And of course, if you want to add more features, just go back to the repo itself, and then go more fancy. You can integrate with other Azure services. You can go with more advanced samples like listing scenarios and what have you. You can also see here a flight map, real-time monitoring dashboard using the SignalR service. You can see more samples that you can use. This one was for the earlier version, which is the SignalR with .NET. Here, if you want to integrate with other Azure services like Azure Functions, creating a web app, deploying the web app, and you can also do so with a Docker image. And in that application, when you connect it, it has the right configuration so that you connect to it. As you can see here now, you can open it with the Azure websites directly. as I told you, lots of things that that you can use. Let me check. What did I miss? This is a flight map, real-time monitoring dashboard. You can see a live demo. Let's see the live demo here. Very simply, how it works: you have an Azure blob, which includes the flight data, and that is sent to the web app. Flight data, the web app is of course sending flight data to the SignalR service that is also pushing it to the clients. You can easily deploy this to Azure and see how it works. And as you can see here, this is the flight data scenario. Doesn't have much here on the map, but you can check the code and see that how is that deployed to the web application. I need to, of course, once you deploy it, you need to change the storage account so you are able to get the information that you need there. But this, for example, on this map, all of this is being retrieved from a storage file, and then it's pushing that information here to the client. There's something missing here because that should update flight data, which is not popping up here, but I think there's a misconfiguration in the storage file. But once you go to the to this GitHub repo, you'll be able to fiddle with it. It's a JSON file. I think it should be somewhere in the repo. Well, basically the JSON file, you can just go and update it. Will have the position, time, lat, long, and you update these, and there's an array that has this format. And once this is updated, or you can also use a simple data generator, and it will start showing you more relevant information here. So we're 5 minutes beyond. I'll pause here and I'll see if we have more questions. If we don't, we are on the clock. Thank you for hosting, and thank you for sharing your time with me. Hopefully this was beneficial. Maybe post the session, we can send you the links, but as I told you, all these links are public, and please go through them. It has a lot of information that is valuable. Hossam, over. If I can sip my tea.
Thank you so much, Rami. Always great supporter and sharing your experience with our community from day one at the Reactor in Abu Dhabi. I'll start just sharing a few things with the community, quick reminders. And as you mentioned, you will be providing some of these links to the resources, the GitHub repos, and also I will also share that with the community. So make sure you're part of the meetup on Reactor Abu Dhabi. Starting to share my screen very quickly, taking over. Yes. All right, yeah, a quick reminder here, we're doing the survey across the reactors. Each event has an event code, and this is for you as a community member to tell us more about the topics that you would like to see more at the reactor. So please take a couple of minutes to fill that and send us your feedback. I would like to highlight also a interesting session we're doing tomorrow with Rory Preddy. Rory is a cloud advocate at Microsoft, and we're doing a session on the cognitive services and the image analysis. There are some new updates and features that you can leverage, and we will be highlighting that on that session. We also are doing so many interesting and diverse topics also this month, so check out the meetup for more. There are workshops on Wednesdays where we cover a diverse number of topics. So the coming one will be on building a web app with ASP.NET. We have the week after building mobile apps with Xamarin. We have exploring logistic regression on the week after, and so many diverse topics. So make sure you check out the calendar on meetup.com and register for these events. Yeah, follow us on Twitter, connect with us. The hashtag is Reactor Abu Dhabi, and subscribe to the YouTube channel. This is where you will find today's session and many other sessions that are coming from Reactor Abu Dhabi and the reactors across the globe. We have them there. It's on demand. If you miss anything or you want to review any of the topics, this is where you will find them. And you can also subscribe to our newsletter. That's where you will receive a monthly curated email about all the interesting happenings across the reactor. So check that out and join our newsletter. That's all for today. Thank you everyone for joining us, and we look forward to seeing you in an upcoming session. Goodbye.
Thank you.